and welcome back to this channel. Dear students, this topic is PIC 18 microcontroller interrupt structure. From the exam point of view, हम लोग क्वेश्चन क्या एक्सपेक्ट कर सकते हैं इस टॉपिक के लिए? ड्रॉ the internal diagram of interrupt structure for PIC 18 microcontroller and explain it, or what are the steps of executing an interrupt, or the question can be like this: what are IVT, ISR and peripheral interrupts, or the question may be related to the register which is used to control the interrupt actions. So we'll discuss all the things in detail in this session. First part, what is an interrupt? जैसे हम लोगों ने 8051 में लर्न किया है, interrupt is basically an external signal, rather it is external asynchronous signal. So when it is arised, the microcontroller executes the current instruction and jumps to the instruction interrupt service routine to provide the services to, let us say, input output devices and so on. So definition of interrupt is, it is external input that informs microcontroller to fetch new subroutine in order to offer services to input output devices. Then let us discuss the question, what are IVT? IVT is basically interrupt vector table, then ISR interrupt service routine and peripheral interrupts. ये जो term है peripheral interrupts, this thing is the interrupts generated from peripheral devices like input output devices or ADCs and so on. Every interrupt basically needs ISR, that is called as interrupt service routine. Every interrupt has a fixed location in the memory that holds the address of that particular ISR. मतलब हर एक interrupt के लिए एक interrupt sub routine चाहिए. इसका address, the address of interrupt sub routine is stored in the memory of microcontroller. Such a group of memory locations, ऐसे बहुत सारे memory locations है जहाँ पे ISR के address store के related to the particular interrupts. Such a group of memory locations is called interrupt vector table. Then the steps for execution of interrupt. One more thing, ये interrupt vector table में जैसे मैंने बताया कि बहुत सारे memory locations है, बहुत सारे addresses है that refers to the particular interrupt. There are again two types of main interrupts. One is low priority interrupt and another is high priority interrupt. ये हम लोग डिटेल में लर्न करने वाले. Presently, the address assigned to high priority interrupt is 0008 hexadecimal, and for the low priority interrupts, this address assigned is 0018 hexadecimal. Now let us discuss steps for execution and interrupt. It is similar to that of 8051 microcontroller. जैसे देखो, whenever interrupt occurs, microcontroller is performing some task. It is executing some program. So, whenever an interrupt occurs, microcontroller executes the present or current instructions and it saves the address of next instruction in the stack. So, whenever interrupt occurs, you see microcontroller completes current instruction and saves address of next instruction on the stack. The current status of all interrupts is already stored, saved internally in the microcontroller. Then microcontroller jumps to IVT. IVT का मतलब है interrupt vector table, जहाँ पे memory, जहाँ पे addresses है हर एक subroutine की, interrupt subroutine के. So microcontroller jumps to IVT, which has address of ISR. Then my third step, microcontroller executes ISR, मतलब it provides service to that particular device which is asking for the interrupt. So microcontroller executes ISR till it reaches, ये important है, till it reaches this instruction. मतलब हर एक interrupt service routine complete करने के बाद microcontroller should start executing the main program which it was doing earlier. तो ये इंस्ट्रक्शन जब भी आएगा, मतलब RETFI, return from interrupt exit. So whenever this instruction occurs in the interrupt service subroutine or interrupt service routine, then in that case the microcontroller returns back to the main program. So Fourth step is MUSI returns to the main program. So these are the generalized steps for execution of an interrupt. Let us discuss sources for interrupt operation. Sources means three usual bits are used which are related to interrupt operation. First is IF bit, that is interrupt flag bit. So this is the flag indication. So naturally it gives indication that interrupt event has occurred. Then IE bit, that is interrupt enable bit, allows the program execution to branch to the interrupt vector address. And third bit is interrupt priority bit. It is related to assigning high or low priority to the corresponding interrupts. Then we will discuss different types of interrupts which are available in PIC microcontroller 18F. So first interrupt is timer flag interrupt. So it is related to timers or counters. It is the flag indication. Whenever there is overflow of timer or counters, a particular flags gives these indications of overflow. So for example, it is TMR0, that is timer 0 interrupt flag, that is interrupt overflow flag. Same way we have TMR1IF. So it is flag related to overflow, flag related to timer 1. Whenever this overflow occurs, the microcontroller gives attention, provides services to the interrupt service routine, and then these particular flags are cleared. Second type of interrupts are serial port interrupts. As the name indicates, it is related to the serial port of PIC microcontroller. So there are two pins, two ports, that is TX, that means transmitter interrupt flag, and RC, that is receiver interrupt flag. So one is related to transmission of data bytes and another is related to reception of data bytes. Whenever such interrupts, this interrupts occurs, the program controller goes to the location 0008H. Third type of interrupts is external hardware interrupts. There are three pins, INT0, INT1, INT2, where we can connect external interrupts. So these pins, I mean three signals, INT0 interrupt, external interrupt signal 0, 1, 2. These are related or available on the pins RB0, RB1 and RB2 of the PIC microcontroller. So these pins are enabled, I mean external hardware interrupts are enabled by using the contents of INTCON, interrupt control register. Next type of interrupts are port B change interrupts. In case of port B, the four pins, namely RB4 to RB7, are used for detection of interrupts. Whenever there is a change, some change occurs related to these pins RB4 to RB7, then interrupt is detected. Actually these are four pins, but it is treated as a single interrupt. So it generates an interrupt which is called RB change interrupt, क्योंकि ये change मतलब इस पिन पे कुछ change, कुछ modification करने के बाद ये तैयार हो रहा है. So it is RB change interrupts. It can be enabled by using RBIE, that is RB interrupt enable bit in interrupt control register. The major application of this type of interrupt is for keyboard interfacing. ये हो गए main interrupt के types. Now let us discuss how to assign the interrupt priority. देखो reset करने के बाद मतलब after resetting all interrupts are assigned a fixed priority, that is all interrupts are assigned a high priority. High priority are having the address 00008H in the memory location, whereas low priority are related to address 18H in the memory location. So as I mentioned, after resetting all interrupts are assigned having a higher priority. The IPEN, that is I bit of Archon register, that is used to decide the priority, or I mean to have the two priorities, either low or high priority. So if this pin interrupt priority enable bit, that is IPEN, interrupt priority enable bit is 1, then only you can assign high and low priority to the corresponding interrupts. So this is about assigning the interrupt priorities. Next part is legacy and priority mode of interrupt structure. From the exam point of view, you may expect the question like this: draw the diagram for legacy and priority mode and explain the internal structure of interrupt in PIC 18F microcontroller. So this diagram is for legacy mode. जो हमने डिस्कस किया है वो सब एक डायग्रामेटिकली रिप्रेजेंट किया है. So we already discussed TMR0 IF, that is interrupt flag, interrupt enable bit. ये जो part है, this part, I am talking about this part, it is related to core interrupts. So I am using AND gates. This for second AND gate, other core interrupts are connected. Likewise, depending on the number of core interrupts, number of AND gates will be using, and all these output of AND gates are applied to the OR gate. Then this part, second part of this diagram, is for timer 1 interrupt flag, timer 1 interrupt enable, and other peripheral interrupts. So this part, second part, is for peripheral interrupts. So core interrupts and peripheral interrupts are shown in legacy mode of interrupt structure. This is PIEI, which we will be discussing after this in the same session. Then output of this diagram will be interrupt signal given to the CPU. Next is the priority mode. Again the logic remains same, INT0IF and INT0IE, these are applied to this AND gate. Then IP, IE and IF, that is interrupt priority, interrupt enable and interrupt flag. These are the three modes given to the AND gate. Likewise, depending on the number of signals, we will be using number of AND gates. Again the outputs of AND gate are applied to OR gate, and these last gates are for first AND gate generates high priority interrupt to CPU. So naturally another input to this AND gate is GIEH. ये भी हम लोग global interrupt enable जो है वो discuss करने वाले हैं. Similarly, this is global interrupt enable for low priority. So one is for high priority, another is for low priority. So naturally this first output is related to high priority to CPU. This last output is low priority to CPU, and this middle OR gate generates wake up call to the CPU. So this is the internal diagram structure which is legacy mode and priority mode. Now an important part, that is INT-CON register, interrupt control register. You can expect a separate question related to this. Explain special function register, that is SFR, for interrupt structures, or explain the contents of INT-CON register for interrupt structure. So this is the diagram which shows how this INT-CON register contents are used. Bit number 7, that is MSB bit, is GIE or GIEH. It is global interrupt enable. As the name indicates, this bit is responsible for indication of global interrupt generation. So there is one pin, that is IPEN, interrupt priority enable pin. This is the content of our con register. We have already discussed this. If IPEN is 0, then this condition must be occurred. If IPEN is 0 in the Archon register, and then if this bit is 1, it enables all unmasked interrupts, and if it is 0, it disables all interrupts. Then if this pin, I mean this bit, IPEN bit is 1, and if this GIE bit is again 1, it enables all high priority interrupts. That's why this H is there. So whenever this is 1, I mean IPEN is 1, and if this bit becomes 1, it indicates it enables all high priority interrupts, whereas when this is 0, it disables all high priority interrupts. Next, bit number 6, जैसे ये हाई प्रायोरिटी के लिए वैसे ये लो प्रायोरिटी के लिए, बेसिकली इट इज PIE और GIEL. L stands for low priority. So it is peripheral interrupt enable bit. PIE is peripheral interrupt enable bit. It is same like this. मतलब ये जैसे IPEN 0 है तो ये peripheral के केस में इस केस में ऐसा लिखेंगे, one indicates or enables the unmasked interrupts. In case of unmasked, we will say 1 enables all peripheral interrupts and 0 disables all peripheral interrupts. सेम लिखना है, सिर्फ यहाँ पे अनमास्क के बदले में पेरिफेरल आएगा, और यहाँ पे हाई प्रायोरिटी जहां है वहां पे लो प्रायोरिटी आएगा, बिकॉज इट इज रिलेटेड टू लो प्रायोरिटी बिट्स. देन बिट नंबर 5, timer 0 IE. So it is timer 0 overflow indication. If it is 1, it is enabled, and if it is 0, it is disabled. Then next bit number 4 is INT 0 IE. अब देखो INT 0 is basically external interrupt. So this is external interrupt enable bit. If it is 1, it enables INT 0, मतलब external interrupt is enabled. If it is 0, external interrupt is disabled. Then RBIE. RB port is related to producing an interrupt that is called RB change interrupt. So RB port change interrupt enable bit. If it is 1, it is enabled. 0, it is disabled. Next timer 0 IF. ये जो interrupt enable bit है, this is the flag bit because it is IF. So timer 0 overflow interrupt flag 1 है, तो it indicates this. If this bit is 1, it indicates that there is a overflow of timer 0. If this is 0, there is no overflow of timer 0. Then INT 0 IF, जैसे ये INT 0 IE है, मतलब जो external pin है INT 0, it is interrupt enable bit. This is flag bit. So INT 0 external interrupt flag bit. If this bit is 1, it indicates that the interrupt has occurred. If it is 0, interrupt is not occurred. Then last is bit number 0, LSB bit, that is RBIO. So RB port change interrupt flag. It is basically giving indication that there is some change in case of RB port. So if this bit is 1, it indicates that at least one of the pins, जैसे ये हम लोगों को पता है bit 7 से pin number 7 से pin number 4 तक pins यूज कर रहे हैं. So if this bit is 1, it indicates that at least one of the pins out of this is changed. Out of pin number 4 to pin number 7. If any one of the pin is showing some change in its status, then this bit is 1. And if it is 0, it indicates that there is no change in the status of all pins. So this is about the special function register used for interrupt controlling. So dear students, that's it for today's session. So thanks a lot for watching this video.